Alright, let's talk about solving quadratic equations by factoring. Now, in order to solve equations by factoring, we need to know about the product of zero rule. Now, basically, if you have two things and they're being multiplied together and they equal zero, one of them has to be the zero. So, we're going to try to solve and figure out what numbers we can put in for x so that these two expressions are going to be the same. Now, in order to use the product of zero rule, you need to make the equation equal to 0. So we're going to need to move that 4x to the other side. Now, if it's positive on the right, it's going to be negative on the left. So we get 7x squared minus 4x. That's going to equal 0. Next thing you need to do is you need to factor. Because we need two things that are being multiplied together. Now, 7x squared minus a 4x, they both have an x in common. And if you factor out one of the x's from the 7x squared, you're going to be left with a 7 and an x. If you factor out the x from a minus 4x, you get a minus 4 equals 0. Now what you're going to do here, now that we have two things being multiplied together, which basically means that this is basically the A, and this is pretty much the B. All you have to do is figure out what each one would be if they were the 0. So if that x equals the 0, we get one of our answers of x equals 0. Or we can have the 7x minus 4 equaling the 0. Now you have to solve for x. This goes back a long ways. We need to add 4 to both sides, and you get a 7x equals 4. When you divide by 7, you get x equals 4 sevenths. So to solve this particular equation, x can equal 0 or 4 sevenths. Alright, let's look at a different one. And we're going to follow the same rules, so the first thing we need to do is we need to factor. So we're going to take the a times that last number c. So we end up with a negative 12. Now if we're looking at factors of 12, you can have a 1 and a 12, a 2 and a 6, and a 3 and a 4. Now if we want factors of 12 that need to add to a negative 4, the only thing we can use for that would be a 6 and a 2. If the 6 was negative and the 2 was positive. So you're going to put those in parentheses with x. You have x minus 6 and an x plus 2. Now, here in my class, you know that you're supposed to check for the 1. It's invisible, so I don't need to put anything underneath the 6 and 2. Now, if you make the x minus 6 equal 0, then x equals 6. If you make the x plus 2 equal 0, then x is going to be negative 2. I do not usually solve these by writing them down. I go from here to here. And the way that I do that is I say, what number minus 6 equals 0? It has to be 6. X plus 2, well, it'd have to be a negative 2. In other words, you're always going to need the opposite number in the parentheses, just like we did with parabolas in vertex form. Alright, let's look at some more. Now, this equation, not a trinomial, but it is a difference. Oh, you see, you can't see that at all. Let's try this one. This is a difference of squares. So if I take the square root of x squared in 100, we can write x minus 10 and x plus 10. Now if we just look at these, and we'll use some logic, number minus 10 is 0. Well, that first parenthesis, x has got to be a positive 10. The second parenthesis, x has got to be a negative 10. It's easy as that. The hard part about these is you have to factor them. Now, you can also write this as plus or minus 10. Doesn't matter. Just pick something. Now, example number 4. This time we're looking at a trinomial. And we have a trinomial where you've got an a. Oops. I hate when that happens. Let's move that over. Okay. Now, 4 times 6, we're going to end up with a negative 24. Now, if you're looking for factors of negative 24, we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, if I want factors of 24 that are going to add to a positive 5, the only thing I can use is an 8 and a 3. And the 8 has to be the positive number. We found our factors, so we're going to have an x plus 8 and an x minus 3. Now, as always, you got to check for your a, so you're going to put a 4 underneath the 3 and the 8. When you reduce this first fraction, you get an 8 plus, you don't get an 8. You get an x plus 2. Now, this particular fraction, if we're going to use the bottoms up, we get a 4x minus 3. And that's going to equal 0. Yay us. Now, when you solve these, we know that the x is going to be a negative 2. That's from this one. Now, if we have a 4x minus 3 equals 0, and we add 3 to both sides, we end up with 4x equals 3. Divide by 4, and you end up with x equals 3/4. Now, you remember how we talked about bringing a number outside of the x? You do the opposite. I want you to look at that 3/4. And look what I had way back here. That was way before bottoms up. I ended up getting the same answer. So, if you're looking at a fraction like this, and you have a 4x, can't see that, and you have a 4x minus 3, all you have to do is undo the bottoms up, and you get your factor. Now this time we're going to talk about going backwards. Now if we go backwards, it's not a big deal. These are the roots. These are the answers. They have already had the opposite of the number in the parentheses. So if I want to write a quadratic equation from 2 given roots, all I have to do is put these back in the parentheses. I had an x minus 3 and an x plus 4 equals 0. From there, some of you like to FOIL, some of you like the box method. And it really doesn't matter. If we go ahead and use the box method, get x squared minus 3x, 4x, and a negative 12. So I end up with an x squared plus x minus 12 equals 0. Now if I'm looking for an equation of a graph, I would have x squared plus x minus 12 equals y. And you can use this method for either one of these. Oh, that was a horrible cloud. Let's try it again. Yay me! Let's go and try this one. We want to get these roots back into some parentheses. So we get an x plus a 3/5 times an x plus a 1. Now, some people are getting confused as to when you put the bottom up and when you bring the bottom down. And here's the basic rule. If you're trying to get rid of parentheses, you move the bottom down. This is going to give you your roots. If you're trying to put the parentheses back, which means we need to multiply. Multiply with parentheses. Then you're going to put the bottom up. This will get us our factor. So, I'm trying to multiply this out. In order to do that, I need to multiply, so I'm going to put my bottom up. We end up with a 5x plus 3 times an x plus 1. And when you do the box method on this one, 5x and a 3, x and a 1, we end up with 5x squared, a 3x, a 5x, and a 3. So my equation would be 5x squared plus 8x plus 3 equals 0 or equals y. It depends on what you're trying to find. Alright. We're going to do that last example on its own, and this is the last one, I promise. Okay, the only reason I put this one in here is because it looks like we only have one number. But this is a parabola that's not doing that. Let's try this again. It's a parabola that's hitting right on the axis. This is a double root. And what that means is we actually have two parentheses that look exactly the same, which is why nobody bothered to write it twice. If you're trying to multiply these together, you are going to have to put the bottom back up. So you end up with a 4x minus 1 times a 4x minus 1. And if we're going to draw the box there, we end up with a 16x squared. And I should have left more room for that one. Minus 4x, and a positive 1. So, my final equation is 16x squared minus 8x plus 1 equals y. Ah, we finished the equation. Yay us. Alright, that's it. I'll let you go. Enjoy your notes.